Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about example of transformation of random variable. And this is the previous examination question. The example is a random variable x is uniformly distributed on the interval minus p by 2 comma p by 2. X is transformed to new random variable y is equal transformation of x, which is equal to a tan of x, where a greater than 0. Find the probability density function of y. Coming to the solution, so given that the random variable x is uniformly distributed random variable over the interval minus p by 2 comma p by 2. So we know that the probability density function of uniform random variable is small fx of x is equal to 1 by b minus a over the interval a to b. So this is the standard expression. This is the equation of the probability density function of the uniform random variable over the interval a to b. So now here the interval, now here given data x is uniformly distributed random variable, interval is minus p by 2 comma p by 2. So using this standard equation, first calculate the probability density function of the random variable x. Fx of x is equal 1 by p by 2 minus p by 2. So reducing the denominator term, we get the probability density function of uniform random variable over this interval is 1 by p. And after that, now where the random variable x is transformed to another random variable y. So given that where the transformated random variable y is equal transformation of x, which is equal to tan ax. So from this equation, x is equal to tan inverse of y by a. X is equal to tan inverse of y by a. So we know that one-to-one transformation or monotonic transformation, the probability density function of random variable y is probability density function of random variable x into determinant of dx by dy. So this is the equation of one-to-one transformation or monotonic transformation. So using that expression, the probability density function of the transformed random variable y is fy of y is equal fy of y is equal. Now here fx of x is 1 by p, that is already calculated, into d by dy into x. Now here the x is tan inverse of y by x. Dy into tan inverse of y by x. So fx of x is 1 by p. So derivative of the tan inverse of y by a is 1 divided by 1 plus y by a whole square. And here take the LCM. The LCM is a square. Therefore fy of y is equal to 1 by p into a square by a square plus y square. So which is equal to a square by p into a square plus y square. So this is the probability density function of the transformed random variable y.